Welcome to today's webinar, How to Architect and Deploy a Multi-Tier SharePoint Server Farm on AWS. Our presenter is Ulf Schoo, Solutions Architect, and our moderator is Colin White. Colin?
Thank you, Carrie. Hello, and thank you, everybody, for joining us today. Today we're going to learn about implementing SharePoint 2010 on the AWS Cloud. We will go over our reference implementation guide, which outlines an example architecture which you can use to set up your own solution. It includes a set of 4 CloudFormation templates as well as sample code that can be run to automate and repeat deployment. Presenting today is one of the main creators of the guide, Ulf Schoo. Thank you for joining us today, Ulf.
Thank you very much for having me. And good morning, everyone. Let's dive right in and talk about SharePoint 2010 running in AWS. I'm going to talk about a couple of things first. First, I introduce you to some of the key concepts within AWS for those of you that are new to AWS, so you have a better understanding of how the different pieces fit together given the AWS infrastructure. Secondly, we talk about a little bit in general about running Microsoft workloads on AWS, any Microsoft workloads on AWS. Then we dive into the SharePoint server architecture on AWS. We talk about some of the common SharePoint server scenarios in the AWS Cloud. And we talk through mapping the typical SharePoint scenarios to AWS from the perspective of the network setting, the routing setting, security group setting, server setup and configuration, including Active Directory SQL Server. And then we talk about some of the deployment options that Colin already mentioned for a repeatable, reliable deployment over and over again. And last but not least, we point you to a couple of resources that are available to you that you can work with, and we can start out with. So with that, let's take a look at the current landscape of the existing enterprise IT challenges that many of us are facing today. The business growth that we see all across the board, IT is in the position or needs to be in the position to meet that business growth. Time to market with new initiatives, time to and resources and technologies to provide insights into the business leadership to accelerate business growth is absolutely paramount and critical to every business today. Combine that with a proper scalability and elasticity of that to meet the growth and the varying ups and downs and the seasons of the business as the business goes is another key aspect that the IT leaders today are considering and that they are thinking through. That combined with some of the limitations we all are experiencing around data center footprint and data center capacity and capabilities is just another area. Do I have enough capacity in my environment to go ahead and set up a new farm in parallel to my existing environment? Do I have the physical space that I need to host additional equipment? And even if I have the physical space, am I properly equipped for cooling and electricity, standby generators and stuff like this that you need to ensure continuity of your business and proper operation of your data center? In addition, we might find ourselves today put a little bit in the corner with regards to an inflexible architecture. Inflexible insofar that the investments we have made, we obviously want to harvest in the best way possible. That means we want to see the best use out of the hardware investments that we've made. However, often we find ourselves in the situation that once we made the initial architectural decisions and ordered the hardware we need to deploy a large SharePoint farm, these initial estimates may be already outdated by the time we get from the test phase, pre-production phase, into putting this whole environment into production. So flexibility is a key challenge. On top of it, there is certainly the challenge of providing disaster recovery and high availability. Not every one of us has the ability to build a second or third data center that is geographically distant from the first one and provides the proper environment for disaster recovery, business continuity, or general high availability architecture. And last but not least, one of the key challenges for all of us is finding and retaining the proper IT talent to actually maintain the infrastructure and build out the environment that we want to see. AWS can help you pretty much on all of those fronts. All right, if you think about the upfront investments that you would have to make in order to build out a SharePoint farm, depending on size, you're easily in the category of 8 to 10 servers that you would deploy, and that means investments in the thousands and tens of thousands, depending on size, even hundreds of thousands of dollars in hardware, physical hardware from networking equipment, routing equipment, to the hardware, to the storage devices. On AWS, you pay only for the infrastructure as you need it, right? So you always just order and spin up whatever you use for your current architecture and for your current environment. All that at a very low pay-as-you-go, low ongoing cost, and there are different type of costing models that we can work with you with regards to reserved instances, and that actually spreads out the cost over a longer period of time and gets you a greater return on your investment. Combine that with flexible capability. So having the flexibility to start with a target design, bring this target design into production, and if things change, be easily able to actually adjust to change. Let's say you're running a campaign at a certain time of the year, you expect a larger than usual workload on a public-facing website, and you need to quickly deploy additional web front ends for your SharePoint farm. The AWS Cloud gives you the ability to literally, within a few minutes, to spin up additional web front-end instances, join them to the domain, and add them to the farm and the site collection. That all leads obviously to speed and a super high agility that you achieve in your deployment. The time from creation from thinking through the architecture to deployment is no longer weeks and months. It becomes a matter of hours to actually deploy the infrastructure as you need it, when you need it, with the size that you need, with the least possible investments. And last but not least, by deploying within AWS, you actually focus on the application itself. Many of us and many of you that are listening are writing custom code, custom plugins for some custom web parts for SharePoint, and there's a lot of IP that goes in it, custom workflow processes, custom code to perform archival of specific type of documents or specific type of code or assets that you may store in your SharePoint deployment. So by running within AWS, you actually have the opportunity to focus on what's your key competency and don't have to worry about building up racks of hardware provisioning and configuring networking environment. Last but not least, today you may be a small business that does its business in one part of the country. Over time, you have aspirations and your business supports it to grow, maybe even globally. So the AWS Cloud provides you the ability to actually grow from the smallest possible, from the smallest footprint to the largest possible enterprise scale environment that your business may need and may require. With the AWS Cloud, we have a couple of foundational services: compute, storage, network, database services. These are the low-level building blocks of the AWS Cloud. On top of it, we have higher-level building blocks around parallel processing, elastic MapReduce, importing, content delivery, application services, search services, cross-service features around deployment and automation, and we dive into some of those, monitoring features, security authentication authorization features, and last but not least, a whole set of tools to access the service and to build out larger scale deployments, some of which we will talk about today on the webinar. Talking about the global infrastructure, just to give you an idea of the scale and the reach that you have within the AWS infrastructure, we currently have 9 regions around the world for a total of 25 availability zones. For you, the audience that thinks in terms of on-premise environments, and for lack of a better word, in the AWS Cloud, think of an availability zone just as a second data center that you have at your disposal that you can use in your architecture for architecting high availability or disaster recovery scenarios. And we continue to expand as our customers are growing around the world, and our customers are telling us where they would like to see additional capacity, and we obviously follow the lead that our customers are taking there. A couple of key AWS services that we will talk about today and that you will hear in the presentation. There is the concept of the Amazon virtual machine, which we call an AMI, Amazon Machine Image. This is a virtual machine configuration that you can launch on the service that spins up an environment concretely for you. If you launch a Windows AMI, a Windows Amazon Machine Image, it provides you a virtual machine provisioned with the Windows operating system. These AMIs are used to spin up and create instances in the AWS Cloud, and there are 2 modes still available. One is EC2 Classic, which basically standalone instances that you do all the configuration and that you connect in the way you like to see them. And there's the VPC, the Virtual Private Cloud Environment, a private carved off part of the overall cloud environment over which you have full control with regards to networking, security, address space, etc. All this in different type of availability zones and within the region. So it's totally easy to think about that you duplicate an environment, and that's exactly what we will talk about when we think about architecting SharePoint in the AWS Cloud. For storage purposes, we have the Elastic Block Storage service within AWS. This is storage that you can provision almost limitless to each instances and for your own use. There are some limitations that we work with regards to the Windows environment and how many mount points you can have on a per instance basis. But in general, these are your hard drives that you would put into a normal rack. Here it's just part of a service, and you attach those resources to your instances that you have created from an army. You have opportunities to easily snapshot those volumes for the purpose of having a point-in-time image of what has been configured or created, and these snapshots can be stored in a highly durable environment like in S3 buckets. For the purpose of talking about SharePoint in AWS, we talk about the virtual private cloud, the AWS virtual private cloud. This allows creating a VPC environment allows you to launch AWS resources in a virtual network that you define, that you have full control of. The environment in itself resembles very much a traditional network that you used to from an on-premise environment. You have control over the subnetting. You have control over the subnet CIDR blocks, the address ranges. If you would have a VPC like that you connect to your on-premise environment, you have control over ensuring that address ranges are properly aligned and don't overlap your on-premise environment. You have control over the routes that you define, and good architectural practices that you can establish there are just the same as within your on-premise environments. And you have gateways either into the public internet or into your on-premise environment via VPN. So just to visualize what I just talked about, from your physical data center, you can have the resources. You could have an Active Directory running in your physical data center. You then connect via VPN, or we have another service called Direct Connect, which provides you a dedicated line that can be much bigger than a normal VPN connection. And connected up to this VPC, the virtual private cloud, and it becomes an extension of your on-premise data center, and all traffic flows in a similar way as it would flow in the on-premise environment. So let's talk specifically about the Microsoft platform on AWS, and to head over actually to talk specifically about SharePoint. In general, you have the opportunity to, of qualifying customers have the opportunity through the license mobility through software assurance program for Microsoft to deploy any Windows Server applications in the AWS Cloud if you have active software assurance in place with your volume license agreement. So on one hand, we have pay-as-you-go ready-made armies provided by Amazon. These are Windows Server armies and SQL Server armies up to the standard SKU, so Web Express and standard SKUs. And we have a license model that is called Bring Your Own License model. That means if you are a qualifying customer under the license mobility through software assurance program, you can bring your own license to AWS and run these workloads in the AWS Cloud. So SharePoint Server and other Microsoft products like Exchange, like SQL Enterprise, like Link, they all qualify under the terms of the license mobility through software assurance program. The armies that Amazon provides in itself are co-developed with Microsoft, so to ensure best practices are adhered to, and we ensure that you have the best experience with these OS licenses that you purchase from us and that you deploy either on a pay-as-you-go basis or over a longer term in form of reserved instances over a 1 or 3 year period. talking about SharePoint and SharePoint workloads now. In general, I think it's clear what SharePoint is there for, and I'm not here to teach you about SharePoint in itself. The usual enterprise collaboration, enterprise content management, team project sites. These are the very typical type of workloads that SharePoint is there, and is a great product to serve all of the customers that we all deal with. On top of SharePoint, you have the ability to build custom web applications for SharePoint services, social computing, workflow, connectivity, individual web parts, and personalization. In addition, search services, the fast server, SharePoint search service, and Office services, Excel, Word, etc. So in a typical environment, we're dealing with two SharePoint scenarios. One is the enterprise internal deployment of SharePoint, which is an enterprise SharePoint farm, where all or parts of the deployment of the SharePoint infrastructure run in AWS, and they are for intranet purposes only. So the user experience that you would have is identical to running in an on-premise environment. The other scenario that we want to take a closer look at is the public accessible web application website scenario, something we see quite frequently out there, and that's SharePoint has proven to be a great environment for this. So web-based applications built on SharePoint Server for a customer service portal, for a customer service portal is probably great, just a great example that we can put out there. With regards to the intranet SharePoint on AWS scenario, you can construct within AWS complete or partial, so hybrid solutions hosted in AWS. It would be an extension of the existing enterprise infrastructure, and you extend it into AWS. This would be typical for corporate group collaboration, content sharing, team sites. And the access to this environment is entirely internal within the corporation. You may have Active Directory on-premise and authenticate using corporate credentials. You may choose to have read-only domain controllers deployed into the AWS environment for fast and close authentication to those resources that are located within your virtual private cloud within AWS. So if we look at the typical Microsoft SharePoint architecture, and many will say this looks familiar, it should be, because it is exactly as you would find it in the Microsoft documentation. So for an on-premise data center, the architecture that Microsoft recommends is very straightforward. You have your domain controller environment that provides authentication for all users in this environment. You have a database set up already here for high availability for a mirrored database with a witness server. You have application server or application server groups, depending on the load that you have and what kind of functions you want to perform. And you have one or more web server groups that are spread out there in order to meet the amount of user requests. All that by a global traffic manager, load balancer, etc., to properly balance the load for the client requests. On the other hand, so this was the intranet scenario. On the other hand, the public website on AWS, so for a public-facing website scenario, you would basically host the entire SharePoint farm on AWS. You leverage the SharePoint server capabilities for web-based application, content workflow, custom code you may write to deliver unique experience to your website, your customer service portal, attendance, and the key points here is that the complete solution is deployed within AWS. It's accessible via the public internet, and you could have the usual constructs like a DMZ in place for threat management, and everything that you deploy there would follow your own architectural best practices with regards to availability, with regards to security, proper carving out the individual instances and securing them from access from the different layers in the topology. So in terms of the Microsoft SharePoint architecture for a public-facing website, again, this is very straightforward. You have, again, your domain controller in this scenario for authentication. You have your database, again, in a setup for high availability, a primary, secondary database with witness. You have your application servers in the application tier, again, one more or groups of them, and the web tier. For a public-facing environment, you may put some UAG or threat management gateway resources in front of it, and you load balance the entire load so that the single point of ingress into the environment is actually the point is the load balancer and the load balancer's address. So let's talk about it, how we will actually take this and translate it into implementing a SharePoint Server Farm in AWS. The approach is exactly the same as you would take on-premise, right? It's in the same stepwise sequential approach. You create the foundational infrastructure, networking, routing, security. You may choose to deploy into a second data center for high availability. In AWS terms, that means a second AWS availability zone. The only thing is you don't have to build it. It is just a click away and available to you to use. And then you go through the usual steps of setting up Active Directory. You make choices about if you want to deploy a single Active Directory site, multiple Active Directory sites. You set up proper subnet structure, site link infrastructure within Active Directory if you deploy into multiple sites. You set up your SQL Server, primary, secondary, witness, and you deploy application and web front-end servers. So the approach that you take to this is exactly the same as an on-premise environment. And the step that comes before that is also exactly the same as you would have in an on-premise environment, because the capacity planning and that you would go through, going through the SharePoint capacity calculators or worksheets that are out there, they all apply in the same way. So the thinking that needs to go up front into deploying an architecture in AWS is not any different than from what you would do in an on-premise environment. So let's take a look at what the architecture would actually look like if we overlay then the typical AWS infrastructure. And you find that it's actually not that different at all. So for the intranet network, you still have your on-premise data center here on the left-hand side on the slides. Your on-premise data center is now connected via a customer gateway, a VPN gateway, with the AWS Cloud and a VPC, a virtual private cloud within the VPC. You come into the load balancer just like you would in in an on-premise world, and then that load balances the web traffic against the web tiers. You have your application tier, your database tier, and your Active Directory in this environment as well. For a public-facing website, again, there is not much different here. It should be no surprise by now. The HTTP, HTTPS traffic from any web browser comes into the Internet gateway that sits in that is associated, attached to the VPC that you launch within AWS. The traffic goes into a load balancer. Global, if you want to use, you can the AWS provided Elastic Load Balancer, part of our services that we have, or you can continue using if you from your existing environment used to like global traffic managers from F5, Citrix, NetScaler, Riverbed, Stingray type of commercial load balancing environment. Those can be deployed within AWS as well, and all these companies have actually offerings within the AWS marketplace that follows the same business model on a pay-as-you-go basis that you could deploy there. So you go into this environment the same way. The web tier is balanced. You have the application tier, deploy one or more server or server groups in there. Your database tier, primary, secondary, and a witness, depending on what choices you make for high availability, and an Active Directory environment. In this case, you would run a full Active Directory within the AWS VPC. Active Directory setup within the VPC is there to provide authentication for the SharePoint farm in general. For the intranet scenario, the Active Directory content from AWS are replicated from an from an Active Directory that sits on-premise via VPN. You would set up actually then in that case individual sites. So there's an individual site, Active Directory site that defines the VPC, and you have your on-premise site. Via the site link, you define how often you want to do the refresh, and you can sometimes, if you have replication times that are typically long because you have actually a large amount to replicate because your user base is very good, very large, you can actually use the usual tools to force a replication if critical updates have been made to the Active Directory, or you can, if you have deployed a full domain controller in the AWS Cloud, you can choose to make changes in the AWS environment first and then replicate back to the on-premise environment. For the public-facing website scenarios, users are created and maintained within the AWS Active Directory. If you have alternate directories, typical LDAP directories within an on-premise environment, Active Directory Federation Service is the tool of choice there, the product of choice, and you would federate between those and the Active Directory within AWS that SharePoint uses to run. Looking at it from an architectural picture, it's very, very straightforward. You have your on-premise Active Directory data center, your on-premise Active Directory domain controller. You have the connection via your VPN gateway and the VPN gateway in the VPC, and replication is just set up between those instances. In this scenario, in this architecture for high availability, we have deployed Active Directory in both availability zones. And for the public-facing website, again, just to give you a picture of how this would look like. Here, your Active Directory is an independent component, integral to the SharePoint farm, but an independent component contained within the VPC running in AWS. All setup, all choices you make are, again, totally the same as if you would make them in an on-premise environment, and you consider that those Active Domain Controllers are in two different data centers. You can choose to leave them as a single site. There are advantages to that, or you can choose to fully build out the site infrastructure with regards to subnets to ensure fastest authentication against the closest Active Directory domain controller for within availability zone. At that point, you then have to ensure that proper replication happens between those sites, and you do this via proper configuration of the site links in Active Directory. But again, there's nothing special here that's going on between or that is in any shape or form different from what's happening in the on-premise world. With regards to the general server setup on AWS, I mentioned it earlier. The first step of any SharePoint deployment, new deployment, or even if you consider upgrading the deployment and revisiting what you have done before moving an environment into the AWS Cloud, you have to go and you want to go through the capacity planning steps and ensure that all aspects of what you want to provide, the amount of storage that you need, the type of servers you want to deploy as a web front-end server, but specifically as a SQL server, that it can meet the load needs that you have based on your capacity forecast. So these steps are critical, but the outcome of this exercise you can directly actually map to AWS specific instance. So you select a specific ARMY for the role, an Amazon Machine Image for the role, be it either Windows or SQL Server. You select an EC2, the Elastic Cloud Compute Service, which is the Amazon Compute Service, the instance type. We provide detailed information about the instance types with regards to CPU, RAM, storage, and networking performance. And all those, think of them as an initial starting point for sizing and testing. Best practices anyway, once you have a target design and a candidate design, and you put it into production, you run your load test against that environment and make sure it performs to the standards that your business needs. And as I mentioned earlier, within AWS, going in this type of iterative process is very easy because you haven't made a commitment with regards to buying a specific server that once you purchase it and you notice that it may have been too small or too big, is now standing around in a data center and is heating the environment. Within AWS, you can easily, within minutes, spin up a new instance, attach the previously used and already configured storage to this instance and launch at a larger instance size should you notice that your SQL Server actually requires higher performance, more memory, or more storage. So you want to go in this iterative approach once you have to start out with this candidate design and you test and tweak to meet your metrics and meet the needs of your specific business. And just to give you an idea of a typical server sizing and how this translates into AWS instance sizes. So you would have from on the top here, you have the typical Microsoft recommendation for web application tier. Recommended 64-bit 4-core, 8 gigs of RAM, 80 gigs of hard drive. This would translate below here then in the table for the web front end like an M1 extra large instance that actually meets these requirements with an army of Windows Server 2008, R2, and IIS installed. And you can look through those tables and you can make actually these type of comparisons. So it goes again back to the point that I made earlier, that the capacity planning you did up front as you would do it for an on-premise world. You take the outcome of that exercise and the recommendation that you draw from that exercise, and you translate it into the appropriate instance size and storage instance size with number of cores, size of the RAM, and attached storage then within the AWS. It is literally that simple to make the mapping one-to-one. It all starts out with what you know from your existing SharePoint environment, and you just simply map it to the instances that you have within AWS. Everything flows from there. For security setup, and some of those websites we realize are especially public-facing websites, may actually have quite some sensitive data. Many corporations use SharePoint actually in a hybrid setup where it's both an intranet site but also a public-facing website for collaboration with their vendors and their suppliers. So there obviously proper security setup is paramount here. So to enable the appropriate access in and out of the VPC, we have two ways of securing that. One way is security groups. Those are stateful and actually define exactly. The security groups can be structured around an individual instance, an individual resource within the VPC, or around an individual subnet, or even attached to an individual network interface. So you have very fine-grained control over what type of traffic you want to see flow between the instances, between the subnets, or between the different tiers of your application deployment. Network ACLs, on the other hand, are stateless. They are controlling traffic specifically in and out of a subnet, and they act only on the subnet level. They're not acting on the per instance level. As I said, the key point here is that network ACLs are stateless. So if you open a port on one part of the subnet, you need to make sure that it's on the other subnet where it's supposed to get into. It's also opened. With security groups, as they're stateful, what goes out also can go back in then into this environment. So putting the pieces together and speeding things a little bit up, for a whole intranet server setup, a SharePoint architecture in AWS would look as follows. Now it's all filled out with a different type of instance sizes, and all the things that we talk about here are actually described in detail within an architecture white paper we have published, as well as a detailed implementation guide that goes through the steps that you take in order to deploy something like this, and the different type of considerations that I talked about here. I had enough time in this webinar to just on a high level touch on. again, the fully fleshed out architecture for a public-facing website would look like that, and is easily to deploy within AWS and works seamlessly and as you would expect it. The tools you would use in this environment in order to, once you have to do deployment of SharePoint more than once, it makes sense to look at the different type of deployment tools that AWS provides. One of the key ones is AWS CloudFormation. It allows you in a declarative fashion to describe the environment that you want to launch in a JSON-based template, and this template then creates a stack where the stack is defined as a collection of related AWS resources. And CloudFormation integrates with other deployment scripts and tools specifically for the Windows side. It's important for us to know that it integrates great with PowerShell. So you can actually use PowerShell encoded in CloudFormation to then perform on-instance configuration at the time of deployment. For example, you want to, when you deploy your Active Directory server, you don't just want to have the server deployed via a standard army. No, you want to actually rename the server. You want to run DC promo on the server in order to promote it to a domain controller. You want to have at least the basic setup of your Active Directory already done with regards to site structure, subnet, site links, so that then subsequent machines that you launch in this environment, that they can then actually be also again be joined to the domain, can be properly renamed with a nice NetBIOS name, and have then the appropriate configuration steps taken care of, going as far as provisioning users and or making changes to a database that's there. As I said, we published all these pieces of guidance that we have collected based on best practices and experience in deploying SharePoint in AWS in an architectural white paper, and that dives in detail into those architectural considerations around intranet scenario versus public-facing scenario, high availability versus disaster recovery scenario, and it's targeted more towards the IT decision maker to understand what is possible within AWS, and then we have also gone ahead and published a couple of articles and implementation white papers, together with a couple of templates that actually allow you to set up this environment. So using the tools that I described earlier, CloudFormation and PowerShell, you can actually set up in 4 different type of templates. So template 1 goes through setting up the infrastructure, networking, routing, security groups, and Active Directories. Template 2 deploys SQL Server. Template 3 deploys the app servers. Template 4 deploys web front-end servers and puts a load balancer in front of it. So all this in a very few steps. You can get up and running in a matter of hours, maybe half a day, and you have the SharePoint farm running within AWS. That's all also described in a quite verbose mode in an advanced implementation guide that not only lays out the individual steps involved, but also teaches those of you who look at creating repeatable deployments via CloudFormation, explaining exactly how CloudFormation applies to deploying Windows-based workloads in the AWS cloud. So, and with that, we are through the main content for this webinar. I hope we were able to point you to a couple of the key things, give you at least on the high level an idea of some of the considerations that go into deploying SharePoint in AWS, and we hope that you took away from it that actually in the end everything that you know already from your on-premise environment applies directly to the AWS Cloud, and the steps involved in order to do proper architecting and deployment of such a solution is not in any shape or form different from what you do in an on-premise world. And where there are differences, we provide you with guidance and written documentation so you can make the proper consideration trade-offs for your specific deployment.
Really quick, one more slide to look at is Reinvent. It's our AWS conference that we have every year. This is the second annual this year in November, and we will be doing a boot camp where our solution architects will go over some of these solutions in person. So a great way to learn a lot of this all at once if you want. And with that, let's get to the Q&A. The first question I'm going to go with is, Ulf, do you have any recommendations on how to keep the content on two different farms synchronized?
Content between, well, let me think about it. Well, there are no AWS provided tools that you would have. So any type of content replication would have to happen on the SQL basis, and any existing commercial tools would be there. I don't right now out of the top of my head, I don't know what the usual tools are there for deploying those, but those would be the same tools that you would use between in an on-premise environment.
Okay, great. A question about testing. Is there a way to test the workload to simulate 50 or 100 or 500 users?
Yeah, again, it would be the same type of test tools that you would use in with an on-premise environment. So if you want to simulate a specific SQL workload, you run SQL I/O against it and see if your SQL Server performs to the I/O capacity that you would expect based on your capacity planning, and see if it does it this way. Other than that, any type of existing or commercial solution for that applies here as well. But again, it's nothing that is there then specific to AWS. Okay,
great. Let's talk about scaling up. Are we able to change the memory, CPU utilization, allocation, et cetera, based on needs after implementing a solution like this?
Absolutely. That's one of the key value propositions, right? So you can only do so much of capacity planning up front. And as I mentioned earlier, often we find that some projects have a longer time horizon based on the customer's environment. So by the time you actually get into production, you've gone through pre-production, you've done your load testing and your performance testing, you put it into production. Maybe in the meantime, the company has acquired another company and needs to add yet another department to the SharePoint farm that will actually put heavy use on it. So it's absolutely easy for you to shut down the instance and start up a new instance with a new instance configuration, so with a new instance type that has then more memory, more attached storage to it, has more vCPUs, so more CPU power for it. So overall, a different performance profile.
Excellent, thank you. And so, in this scenario, you can manage security in the typical way that you would in a SharePoint scenario. But in addition to that, would there also be a way to manage security on the AWS level using IAM accounts or security groups? Maybe you have maybe there's a IT director that wants a certain level. Maybe then you have your workforce that you want to have a certain level of AWS access.
So these are two different things, right? So there's permissions within the SharePoint farm in itself. Those permissions are granted within SharePoint based on Active Directory users and use rights you assign to this Active Directory user. And then there are specific AWS permissions with regards to ability to provision resources, make changes to an overall AWS infrastructure environment. And yes, for that you can have IAM user, IAM roles that can be assigned to different roles within your organization. So for example, you can have a role for the typical network administrator in your organization, and the rights that this person would have is the right to actually only change security groups in order to open ports within the firewall or change the routing within the network.
Awesome, thank you. So one final question as we wrap up here. Can you speak to cost savings between an on-premise solution and running this on AWS?
First of all, the SharePoint license is the license that you bring yourself, right? We said SharePoint is a BYOL licensing model, so there's no cost saving from that perspective. However, there's tremendous cost saving in terms of the overall environment and the infrastructure that you provision, as you only pay for what you use when you use it. So if you design a SharePoint farm for let's say it is a public-facing website and you have an initiative running for during a Super Bowl commercial, you would, in an on-premise world, you would define this scenario and this environment for this maximum workload. At that time, then, this environment would stand for 80% or 90% of the year unused at that type of capacity. So the cost savings within AWS for the infrastructure comes into play when you look at that you really provision what you need when you need it at that time.
All right. Thank you very much, Ulf, and thank you everybody for attending today. I'm going to shift back to Carrie for some info about the poll.
All right. I would like to extend a special thank you to our presenter, Ulf Schoo, and our moderator, Colin White. And if everyone could take a moment to complete